Hi everyone, I hope everyone is having an amazing time at reInvent 2021. My name is Adnan Bilwani and I'm a Senior Specialist for the Builder Experience team here at AWS. Let me also take a moment to introduce you to my colleague, Bobby Hallahan, who's a Senior Solution Architect with our AWS Observability team. And we're both really excited to be here to chat about observability and when it comes to your DevOps pipeline. Quick look at our agenda. Would love to start by establishing some common ground for what we mean by when we speak about observability. Then highlight why observability in DevOps. Next, let's dive deeper into different areas of observability when it comes to DevOps. Talk about this, have maturing term called next-gen DevOps. Share what AWS is doing in that next-gen DevOps space. And last but not least, some key things you can do to get started if you're not already there. All right, so let's take a couple minutes to just speak about what is observability. We all understand and know what observability is, but if I were to just categorize to kind of establish our discussion, right, the concept of observability describes how well you can understand what is happening in the system, often and also on demand. In other words, observability gives you the ability to efficiently detect, investigate, and remediate any ongoing or potential upcoming issue as well. And before we go further, let's talk about some key terms we hear in the observability and DevOps space to kind of build our discussion on. The first is monitoring. Though the term monitoring is sometimes defined as a precursor to observability, monitoring is simply one of several types of tools and activities that make a system observable. In other words, monitoring tells you whether a system is working or not, while observability tells you why the system isn't working. But to make sure you're monitoring and observing your applications correctly, you need to first provide a measurable criteria for success, right? I mean, this is where your service level objectives and key performance indicators or KPIs come in. Before you start observing a system or application, you really need to determine, what's your commitment to your users? What are your users expecting? What service level objectives are you trying to reach, right? This is not only uptime. It could be maintenance, right? Maintenance windows. It could be security expectations. And in some cases, even business objectives. Example, level of throughput to a site, right? And in order to confirm you're sort of meeting your service level objectives or your SLOs, you really need to clearly outline your KPIs or your key performance indicators, or in other words, defining the metrics that you'll be measuring for your success for those service level objectives. And although, a while ago, observability, uptime, SLO was a topic more for sort of sysadmins and ops teams, with the DevOps model today, development and operations are no longer siloed, right? Developers in combinations with SREs and ops staffs are now jointly responsible for the performance of their apps, which means that observability is the concern for both devs and ops, right? So that's where kind of establishing where DevOps sort of comes into play. And then last but not least, let's talk about AI ops, right? Or next gen DevOps, right? It's a relatively recent term, but it's all about how to apply machine learning to your to your operations to find issues or to resolve problems as they come up, right? The main goal from an observability standpoint for AI ops or next-gen DevOps is, how can I find issues before they happen, or how can I find issues I may not even be looking for? So that kind of brings me to the topic of why observability is important with DevOps. So first, as we saw in the previous slide, it's all about giving yourself as developers and operators visibility into how your application and resources are doing. Having this insight into your metrics gives you the confidence, right? That when you make code deployments or infra changes, you can see the impact of these changes and troubleshoot any real issues in real time. And with DevOps increasing your organization's ability to deliver applications and services at a higher velocity, it's only customer obsessed, right? To make sure you do not sacrifice your end user's experience. And as you improve and increase your pace of innovation, you want to make sure you take care of that as you move along. So all this is kind of say, right? Application delivery, performance, and uptime, they have a direct correlation with your business's bottom line. So Let's start now by defining and dividing observability in DevOps into specific areas or segments so we can kind of deep dive and tackle them one by one and talk about observability in each one of them, right? Let's start with the overall observability of a DevOps pipeline, right? With CI/CD, automation, teams and organizations are always working to optimize and speed up delivery of applications. Making sure that your DevOps pipeline is being monitored and you have clear insights into the performance and availability of your pipeline is definitely very important, right? AWS provides you many building blocks to create and develop these custom native pipelines. You might be using third-party applications or services as well. Each of these services, they provide you metrics and logs that can be observed in real time, provide you insights into the health of your system and the health of your pipeline. But observability of DevOps doesn't just end there, right? It doesn't end at just observing your pipeline. This brings me to the second segment of observability, which is observability of deploying from the pipeline. Infrastructure as code, IAC, helps organizations achieve their DevOps goals of automation and service. This practice, right, it supports programmatic build, configuration, and destruction of environments, enabling your organization to have a self-service model, right, to automatically enable and deploy apps while reducing errors and eliminating any of those time-consuming rollbacks. However, a key part of making this process a success is infrastructure monitoring. Having the ability to dive easily and understand and resolve any issues with your deployment, provisioning infrastructure, if there's any issues there, it's really important in maintaining that pipeline as well. This brings me to the last segment of observability in DevOps, right? Traditionally, from a pure operations view, right, responsibility of monitoring your application once it's deployed falls onto IT operations. We always see that sort of happening. You're always talking about sort of how you monitor those, right? So if you look at all those software development lifecycle charts, or you're looking into how your workflow is being set up and talking about application deployments, you're always talking about that monitoring that comes in the end, right? Whether that's by collecting logs or looking at metrics. But that kind of highlights that traditional IT role, right? And it's sort of assumed, right? The operators are responsible for collecting the metrics to determine performance and uptime. And you basically get that typical picture of an operations center within, with dashboards across large monitors and all that fun stuff. That's what comes to mind. However, with DevOps or developer operations, right? No longer isolating your developers from your operations, the changes are becoming, or how do I say this? That process is becoming a little bit more correlated, and it's becoming a little bit more seamless as well, right? Especially now with serverless and microservice architectures leading to those distributed applications, the mindset of observability in a pipeline, while consumed post-development, really truly starts at the developer's end. Which is why, for this reason, let's start talking about observability in a pipeline first from a developer standpoint. So we start speaking about a simple web application, right? Keep that in mind. It's built on a microservice architecture. It's spread across multiple services. As a developer, observability requirements can be achieved by just thinking of how you can incorporate logging, general information, custom information, how you can take advantage of metrics, how you can enable tracing data to provide a richer look into sort of your applications, right? The tools are there, right? You can utilize tools like CloudWatch that lets you take advantage of metrics and logs. You can use AWS X-Ray that can provide you tracing data. That really helps you understand your application flow, determine what's happening, and in other words, right, it helps you sort of monitor and get those details from a developer standpoint, basically. But before we go into details of how and what we can do and the tools, one of the important steps I really want to take a minute to speak about is what and why. In other words, what are the key performance indicators for your application that will provide you the insights and observability that you require, right? Picking the right metrics is sort of step one. Think about what matters to your application. Is it velocity of remediation? Is it number of issues, test coverage, application stability? It could be a lot of different service level objectives that you're looking at. And then you think about what metrics can provide you that data. For example, if you're looking at performance or application stability, can you monitor database transactions, slow queries, I/O latency, HTTP request throughput, service latency? Measuring performance could be different, right, for each application itself as well. So, and then if we talk about DevOps, right, we definitely should mention sort of the key 4 metrics identified by the DevOps and Research Assessment, or as folks know it as DORA metrics, right, as well. And out of those DORA metrics, right, from an observability in a pipeline standpoint, I really believe the change failure rate and MTTR really reflect how well you've set up observability as well in a pipeline. To be able to sort of detect, right, what leads to production failure, how fast can you actually look into those issues with all the development observability changes you've kind of put in place during development as well. So how to start doing this? Well, one of the easiest ways to start observing your applications is AWS X-Ray. It's a relatively simple way to start observing how your application flows through multiple services across AWS. If you have a native AWS environment, you've got a serverless architecture, enabling AWS X-Ray is really a great way to start instrumenting your application and really looking at how metadata is flowing across your application. X-Ray provides you daemons, right? It can be run on AWS Computer Resources, Docker containers, all this can be collected and you can really see that flow go through. X-Ray just simply traces the data from your application, right? And it helps you really visualize and deep dive into what your system performance is. And it can really kind of help you deep dive into some of those metrics and information that you're looking for when you're looking at latency and issues that may occur when your application flows through different services as well. If you're using open source, that's fine. You would like to use OpenTelemetry, no issues, right? Just use AWS Exporter. It's available in the OpenTelemetry collector and send data to AWS X-Ray that way as well. If you want an even deeper dive into your application workflow, CloudWatch can really, not only track recommended metrics, you can actually do custom metrics for your applications as well that are application specific. You can develop graphs, dashboards, statistical analysis on custom metrics, right? And you can do a lot to sort of visualize some of that information and gather that data as well. Think of a lot of things, right? Think of, from a web perspective, like a number of unique page views, time it takes to complete a certain process, tracking various different app flows. Custom metrics really allow you to get a deeper dive into how that is happening and collecting metrics, right, to improve that efficiency, potentially even optimize cost and better focus on your app quickly and really get those trend data as well. In addition to default metrics, right, which are stored at standard resolution, I do want to highlight the fact that custom metrics, right, you can store them at standard or even high resolution, which provides a 1-second granularity. So this high resolution can really help you provide more immediate insight into that sub-minute activity, right, and really can be used to generate alarms more quickly based upon sort of the activity you're setting up as well. All right, so X-Ray traces vended customer metric data, synthetic queries. You can add on Lambda insights. All these can be displayed in CloudWatch Service Lens. Think about how do you want to visualize this data now, right? You've got it all through your in your observability in a pipeline from a developer standpoint. Now let's talk about how you can actually visualize this data as well. And that's where CloudWatch Service Lens comes in, right? It really allows you to easily correlate this information together and really helps you get a deeper perspective of issues you're investigating. So speaking of actually providing you a visualization of how this works and really deep diving into this, I'm going to turn this over to my colleague Bobby to demo this with a deep dive to really show you how to enable this and what it looks like to troubleshoot and investigate these metrics and these features that you've sort of set in.
Awesome. Thank you, Adnan. So let's go ahead and jump right into the demo.
Hello, everyone. Welcome to the demo portion of today's breakout session. In this demo, we're going to take a look at what observability inside a DevOps pipeline looks like. And for this demonstration, we'll be using a pet adoption website This website is composed of several different ALBs that are fronting different ECS and EKS clusters. We also have API gateway and some Lambda functions at play as well. Let's go ahead and take a look at what our website actually looks like. So here we are. This is a pet adoption website. We have the ability to select by specific pet types, different pet type colors. We can search. We can take a look at a specific pet. We can then go and attempt to adopt that animal. And here we can see adoption is complete. In this application, we have a few traffic generators sending requests to the site, making adoptions, searching for different pets, as well as refreshing the pets that are available. We also have instrumented our application with AWS X-Ray, as well as the AWS distro for OpenTelemetry. We're leveraging container insights as well as Lambda insights, and we are collecting application-specific logs and metrics for this application. Now, let's go ahead and take a look at how we can observe our application using these tools. So here we are at the Service Lens Service Map console. In this console, we can see a visual representation of our pet adoption website application. And inside this console, we can see each node as a different service or portion of our component of our application. We can resize our nodes based off of requests, latency, health, or prefer no node resizing. In this case, we'll leave it to request node sizing. We can also take a look at hiding specific canaries or only showing ones with faults, but for now we'll go ahead and hide any canaries we have running. We can also take a look at the different representation of these nodes by looking at a metric for the node, which gives us the average latency as well as requests per minute. However, we can just keep this as an icon. In addition to this, we can take a look and see that for a ECS pet site container, we have specific coloring here that indicates an error rate. We can also see the connections between this node as well as other components in our application, as well as the percent OK. Underneath, we also get a preview of this specific node, so we can see information about metrics, our P50 response time, as well as our P90 response time. We can take a look at the number of requests and faults. In addition to this, we can also view a specific dashboard for this specific node. So in addition to the latency requests and faults, we can also see if there are any throttles, errors, or 200 OKs, and what that looked like. If we scroll down a bit, we can also take a look at a visual representation of this node on our service map, which means we can see all of the other nodes that this node is making requests to, or has made requests to in the past. In this case, since this is a container, we also have the option to view this in Container Insights. From the Service Map console, we can also select different nodes. So in this case, I'm going to select a specific Lambda function. And with some services in Service Lens, as you can see, we still get these same metrics. These metrics are emitted from AWS X-Ray. We can also see a visual representation of which nodes this is connecting to. However, if we scroll down a little bit further, we can see service level metrics and the correlated logs for this specific node. Now, let's go ahead and take a look at what traces we have available to see how we could deeper troubleshoot our application. Here we are at the Service Lens Trace console. This will show us traces from AWS X-Ray, and here we're looking at all of the traces that have happened on our application over the last 6 hours. We have some filtering options where we can filter by X-Ray group. We can look for specific service names or annotations, or we could more refine our query by looking at specific options such as filtering by node, client IP address, or HTTP method, user agent, resource IDs, or specific root cause messages. In this case, we're going to look at specific user annotations. And inside our user annotations, we've added custom annotations to our application, specifically pet ID and pet type. And what we're going to do is filter for pet type. And now we can see annotation.petType. And we can also further refine this by looking for a specific pet type. So now we're only looking for requests where the trace included a pet type in the annotation, And now we're further filtering this for, let's say, the pet type has to be a bunny. Now, here we can see we received 756 traces. We can also take a look at our response time distribution of where our P50 is, where our P95 is, where our P99 is, as well as on the tail end where our higher latency requests are. We can further filter this by looking for specific traces. In this case, I'm going to look for traces that included make payment in the request URI. I can also filter this by specific response time. So let's take a look at one where our response time is a little bit longer. In this case, 1.2 seconds, which is on the very high end of our response time distribution. Additionally, we could also take a look at the overall latency and just highlight a specific portion of our response time distribution. And as you can see, this has now been added to the query. So we can rerun our query and then only pull back results that are for traces that took over a certain amount of time. We can then select a given trace ID. What we see here now is a visual representation of this specific request. We can see all of the nodes that this request interacted with. So we can see where it starts with ECS pet site, and we can see where it goes to pay for adoption. We can also see how we also invoke a step function, and at the end we also end up making a request to DynamoDB. If we scroll down a little bit further, we can see some information, i.e. the method, response code, duration, and how old this trace was. We can also take a look at the specific segments for this trace, looking at a timeline of which requests were made and how long each request took. And we can see this for every component that's represented on the service map. From here, we also have some segment details, so the subsegment ID, parent ID, time, errors and faults, as well as correlated logs for this specific request. Now, where this can be valuable is that you'll notice that we have API Gateway access logs. We have logs from AWS Lambda, back to API Gateway, then ECS, another Lambda function, and really where this helps is that for a given request, we're able to find where that specific error is. And this really demonstrates the power of observability, because we can go from a service map where we can see latency or errors. We can further investigate that by looking at specific metrics to see, is there anything that's specific throwing a fault? We can further refine that by then looking for specific traces that match those patterns. And then using those traces, we can then start correlating our logs to quickly identify and pinpoint where potential application error could be occurring from. This concludes the demo for our session, and let's go back into the presentation.
Now that the demo's been concluded, let's take a look a little bit at a summary of the observability landscape on AWS. So if you move your eyes to the bottom of the slide, you can see we start with an instrumentation layer, where this is where we start collecting our data. This could be through the CloudWatch agent, the X-Ray agent, or even the AWS distro for OpenTelemetry by leveraging the OpenTelemetry collector. With the OpenTelemetry collector, you're able to instrument with an open source specification and then send that data to any number of destinations, one of them being X-Ray, for example. If you move towards the center of that slide, we can see there's a couple different data stores. So where we're storing these distinct types of observability foundations, such as metric storage and CloudWatch metrics, or Amazon Managed Service for Prometheus. Or take a look at log type data, where you can store it in CloudWatch logs or Amazon OpenSearch service. On the right-hand side of the screen, you can even see some of the managed open source offerings we have to really start building out those observations, doing correlation between logs, metrics, and trace data. So one example is Amazon Managed Grafana. However, on the left-hand side of the screen, what we just demoed would be by leveraging the add-on services on top of CloudWatch logs, metrics, and trace data by looking at container insights, synthetics, contributor insights, or even CloudWatch Service Lens, which is where we do our correlation of logs, metrics, and trace data. Now, with that being said, let's move on to observability of a pipeline. And just to summarize, what do we mean by observability of a pipeline? So these are logs, events from our DevOps pipeline. So what type of output signals do we have from our actual pipelines that we can use to evaluate the health and performance of those. The first way we want to do this is by building operational metrics and really understand the health of those deployment pipelines. So this begs the question, why do this? Why do I want to put in the effort to go about determining metrics, determining what those KPIs should be, just about the deployment pipeline? Like, why does this matter? It's going to take some sort of developer investment. It's going to take some sort of people hours to make sure that we have the right data and we're iterating on it correctly. So ask yourself, why do you think this is important? And I'll respond to that question with, I guess, another question, which is, how do you understand the health of your operations? And I'll give bonus points to anyone who knows where this question's from. And of course, this comes from our well-architected review, specifically on operational excellence. Part of a DevOps type culture is leveraging these CI/CD processes to deploy applications and deploy workloads. Operationally, and to be operationally excellent, you need to have those telemetry points on your pipelines. So and to expand on that pillar a little bit, it's all about defining, capture, analyzing operations metrics to gain visibility to operational events so that we can take the appropriate action. So what's that mean? Identifying KPIs or key performance indicators, defining those operational metrics, collect and analyze those metrics, establish those metric baselines, validate the achievement of outcomes and the effectiveness of KPIs and metrics. So what that means essentially is look at our goal, look at the metrics we're collecting, and is that achieving our goal? Does that metric represent what we want it to represent? And is it something that we can work, is it showing something that we can work to achieve or improve? So some examples of operational KPIs, just like Adnan mentioned, we have those DORA metrics, but things like time to deployment, deployment success rate, number of commits, time to build, build success rate, MTTR, all of those metrics can be important. Now, let's take a look at a sample architecture here. In this architecture, we're going to be using the AWS managed services for CI/CD, which is AWS Code Commit, AWS Code Artifact, AWS Code Build, Code Deploy, as well as AWS Code Pipeline. Now, when we think of observability, we need to think of the output signals that are available to us. So what are these services emitting that we can use to evaluate their health? First one being EventBridge. This is probably the richest source of information we can get from these pipeline services. Others being Amazon CloudWatch. For example, Code Build shows CloudWatch logs. Code Commit also displays CloudWatch metrics. Code Build has CloudWatch metrics. And then CloudTrail gives us those control plane API calls. Now, let's first jump into one of the first sources of data, which is CloudWatch usage metrics. And in these usage metrics, we can see various different things from different call counts, API throttles, types of API calls being made. However, like I mentioned, the richest source of data we have is coming from EventBridge. And what this looks like is we can take events from Code Build, go to a default event bus, and then have that write to EventBridge rule, which is going to catch all of those events, which then goes to a CloudWatch log group. We have a similar pattern for Code Commit, as well as Code Artifact. And then, of course, for AWS Code Deploy and Code Pipeline, similar patterns. I also want to highlight that this also works in a cross-account scenario where you can deploy from an event bus in a different AWS account and push those resources in, or push those events in. From here, you also may be asking the question, what if I'm not using these services for my CI/CD processes? And what's important here to focus on is that even though you may not be using, let's say, Code Build for your build process, or you may be using something else instead of Code Commit, maybe you're using Git or a Bitbucket or something. What's important is understanding this process, which is let's look at the different components of our pipeline, understand what output signals we have, and then from there determine how can we build usable metrics from there that we're able to iterate on. So now that we have all of these events from our services inside a CloudWatch log group, what we can do to define those metrics is by leveraging a metric filter. So I'll quickly show here where we're using a detail type, using Code Pipeline, we're setting a metric value, and then we're using different dimensions to extract those metrics for different execution states. In a moment, we're going to jump to a demo where we'll actually highlight this. But filtering for a specific data type, setting that metric value to 1, no default value, and then of course we're leveraging the new support for dimensions in metric filters. So now that we know what these output signals are, and we know how we can extract some metrics out of it, how do we go from our DevOps tools in our CI/CD pipeline to potentially a dashboard over here? And how this looks is, obviously, some of these services emit metrics on their own. Those metrics can go right to a CloudWatch dashboard, which is great. Our metrics, we can also set alarms on those metrics, which can be displayed on a dashboard, even better. We have information from CloudTrail. CloudTrail can go into EventBridge, we can create EventBridge rules to catch those CloudTrail events, in addition to be able to create EventBridge rules that catch all of those events from DevOps. So if you refer to those couple slides previously where we're just filtering everything and catching it. And then, of course, from EventBridge, we write to CloudWatch logs. And then, of course, there's a couple services here that also directly write to CloudWatch logs. And then once we mentioned, we have a few different options from CloudWatch logs to start doing those visualizations. One being contributor insights, logs insights, and most importantly here, and what I think is most useful, is going to be metric filters, where we're able to define a metric out of those logs. And then once it exists as a metric, we can start doing a whole variety of different things with it, including writing it directly to a dashboard, using math expressions, search expressions, or even defining alarms off of those metrics. Now, with that being said, let's take a look at an example of what this looks like in real life.
Now that we've seen the overall architectural approach, let's take a look at this practice in action. Here, we're starting with the AWS CI/CD workshop. In this workshop, we have a pipeline built from a Java application as well as a .NET application that I have running in a separate AWS account. The workshop will set up a deployment and production instance inside of VPC, and will leverage code build, code commit, code deploy, and code pipeline to build out a deployment pipeline for the Java as well as the .NET application. So without any further ado, let's take a look at our first application. Here we are at our .NET application. As you can see, this is a relatively simple application, displaying simply hello world and a random deployment number. Keep note of that number as it will be changing. This is a deployment number that I'm using as a random variable, so every time I publish a new, commit a new version, that number will be updated. Now, let's take a look at our code pipeline. Here we are at code pipeline for our demo app for .NET. As you can see, the source is in AWS code commit, our build is using code build, and our deploy is using code deploy. As well as the last execution, pipeline execution was successful in all three of these stages. In order to simulate an actual development environment, I had to take some automation steps to routinely update this pipeline. Let's go ahead and take a look at what that looks like. All right, so here we are inside a Cloud9 IDE. And what we can see is we have our page, which is a very simple page, which shows H1 hello world, a random number, and then a little survey prompt of testing out with code pipeline. Now, what I would like to show is a script, a simple script that we're running, which will go and, for line 5, replace it with a random number, and save that file back to our index. We'll then add, commit, and push that change. We also have a script that will go ahead and break our application. And here what we can see is we're just taking a bad apt spec file, and knowing that this will actually cause my deployment to fail, I'm pasting it over to where my project lives. I'm then adding and committing and pushing that change. Then, of course, after the fact, I'm just writing the good file back. This is to simulate a deployment failure. Both of these I'm running on a regular interval for the past week or so. But let's go ahead and make a change now. So right now we can see our deployment number is 20553. And we can see it on our application, 20553. If we reload, we can still see it's 20553. Now, let's go ahead and run our script. And we can see that we've updated our change. And we can also see that our random deployment number has changed to 25433, which is definitely different. Now that that's been changed, we can now go see in Code Pipeline where our source was updated. Now we're in a build state, and we can wait until we get to our deployment state. Now that we can see our deployment has been successful, we can now go back to our application, reload our page, and we can see now we have our new deployment number. With all of these changes going on in a DevOps pipeline, we spoke about the different types of events that can be emitted. So let's go ahead and take a look at what those events are and how we're actually capturing them. And this is done through a event bridge rule. In this case, we're looking at one for code deploy. And what we have is a event bridge rule that's capturing every type of event from code deploy, meaning as we have new deployments, new events are picked up, and then they're sent on to the event bus. In this case, we have our default event bus, and our target is an event bus in a different AWS account. Like we said earlier, this .NET application is running in a separate account, so we want to be able to try to centralize those events somewhere else. In this case, we're sending them to the account that's running our Java application. The only thing of note here is that since this is cross-account, we need to make sure that the permissions for the IAM role allow to publish an event to the event bus in the other AWS account. Now, let's take a look at another example of this rule. As you can see, we have rules for code artifact, code build, code commit, code deploy, and code pipeline. If we take a look at our code pipeline rule, it's not that much different. What we're looking at here is an event pattern that's taking all events from code pipeline, including CloudTrail actions, pipeline state changes, execution state changes, as well as action state changes. So we have 3 different types of events, including CloudTrail as a 4th, all writing to the same event bus in the different account. What's nice about the simplicity of this rule is that as we add different pipelines and as we scale out, all of those events will still match and they'll still be sent to the target destination. So there's no additional changes we need to make as we add additional pipelines or additional applications. Now that we've covered the .NET application, let's switch gears a bit and take a look at the Java application that we have stood up. Here we are looking at our Java application. This is once again a relatively straightforward or simple application as a sample web app. And once again, you can also see we have a random deployment number. In this case, it's 18520. Just as we did with the .NET app, let's take a look at the pipeline for this application. We can see that we have a source in code commit, build and code deploy, and our deploy stage is using code deploy. So not that much different than what we would normally see from our .NET application. And similar to our .NET application, we are using a Cloud9 IDE to where we actually build our application. And how we're making changes is very similar to how we're making changes on our .NET app. We take a single line, update that random deployment number, save the file, and then we just add, commit, and push the change. We also have a second script that will be responsible for breaking the build, where we just use a build spec where I know that will cause a specific failure. And just like with the demo .NET application, I've had these running for about a week or so to simulate some sorts of changes on our pipelines and executions. Now, where this differs a little bit is that in the EventBridge rules that we're using. So just with EventBridge, we had in our external account that was running .NET. In this account, we have our Java application running. We have the similar rules for code artifact, code build, code commit, code deploy, and code pipeline. If we take a look at code pipeline, we can see once again it's just covering the base, pretty much everything coming from code pipeline. But in this case, the target is writing to a CloudWatch logs group. Now, we have this rich source of telemetry coming from AWS. We have this rich source of information. We want to think of that as that output signal. The events that EventBridge is sending from these different pipeline state changes, build state changes, commit changes, these are all our output signals. And what we're doing here is we're actually now writing that to a CloudWatch log group, which gives us a long-term durable store for these changes, as well as a place to query against and create metrics from. Now, there are many different types of patterns for code pipeline, meaning that different events may have different event formats. An example of this we could see is just by looking at editing the rule and then defining a pattern. We have CloudTrail, action, pipeline, and state changes. Each of these have a slightly different log format, so one could argue that you may want to put this all into different log groups. However, for the case of this demo, we're all writing it to the same log group. So now let's take a look at the actual log group. Here we can see I have my different CloudWatch logs, and I have my different log groups for code artifact, code build, code commit, code deploy, and code pipeline. If we take a look at our code pipeline logs, we can see we have our different log streams here. To really get an idea of what these logs look like, we can analyze them with CloudWatch Logs Insights. CloudWatch Logs Insights is an ad hoc query tool that allows us to analyze logs by running specific queries on them for specific periods of time. Our commands are pipe delimited, and we have different commands such as field, sort, limit, parse, stats for aggregation. But in this case, we just want to take a look at the message. So we will select the timestamp field, the message field. We'll sort by timestamp in descending order, and we're only going to grab 20. If we scroll down, we can see the different execution IDs, or the different IDs, as well as the detail types. If you focus in on detail types, you'll notice that we have the different detail types from pipeline execution changes, state changes, and action execution state changes, as well as information from CloudTrail. For example, we can take a look at the CloudTrail information, and we can see we have information about the account, region, events, who made the request, what the request was. We also have information about, if we take a look at execution state changes, we can see the state, execution ID, and the pipeline. Or now if we take a look at an action state change, for example, we have the action, which is deploy. We have our pipeline, as well as where the artifacts came from. So once again, this is a very rich source of information. And what I'd like to show is, if we take a look at our fields, we can see the different types of fields we have available to us, such as ID, region, source, version, execution ID, pipeline, state, version, etc. So all of these are different fields that exist within our logs, which we can now leverage something like a metric filter or a one of these queries, which we can then query and then add to a CloudWatch dashboard. So now let's go ahead and take a look at what our metric filters would look like. So here we are back at our log group for code pipeline, and we can see that we created two distinct metric filters, one filtering for the pipeline execution state change detail type, and then the second being a stage execution detail type. Meaning when we have this specific format of log, then that's when this pattern will match, and that's when we'll publish a metric. What's interesting here is what we're doing is we're publishing a metric value of 1. We're not counting a default value. We're just using the count. And then from a dimensions, for every unique combination of these fields in that event, being in this case the pipeline, the stage, and the state, we publish a distinct and separate metric, meaning that for different pipelines, different stages, and different states, new metrics will be added, and then we can start counting that over time. On the other hand, we can also get even more granular or even higher cardinality, where we start looking at our pipeline state changes by execution ID, meaning that we can get a distinct metric data point for every execution ID, every pipeline, and every state it went through. While this may create many CloudWatch metrics, we don't necessarily need to be as concerned about the cost, because we're only publishing the metric once in regards to the execution ID. Now let's look at what these metrics actually look like. Here we are in the CloudWatch metrics console. We'll take a look at our code pipeline stage execution state change namespace. And here we have a single dimensions, grouping of dimensions, which is by pipeline, state, and stage. If you mentioned when I did that metric filter, those were the 3 different dimensions I was using. And if we take a look at our metrics here, we can see that we have different metrics for our .NET application as well as for our Java application, being with different stages, states, and states. We can even see in this case we have a Java app where the build state and failed, meaning that as new states and new pipelines are added to our logs, we're creating new metrics from that. So it's dynamic in nature, which is very interesting. So not only is the event bridge rule, where it's just capturing new events as they come in, being scalable in nature, so are the metric filters. So as we add new pipelines, they're being picked up by our metric filter. In addition to this, if we take a look at our other metric that we created, our pipeline execution state change, we can now see we even have different metrics for specific execution IDs as well. With all of this information, we're now able to actually create a dashboard that shows us the overall health of our pipelines. And here what we're viewing today is a CloudWatch dashboard that gives us some information about our pipeline, being the total number of executions, successful executions, success and failure percentage, this is of course over the period of 2 weeks, success and failure as a stacked time series, total executions by pipeline ID, showing failed and successful pipelines as well, daily execution and weekly execution trends, as well as total counts by pipeline for daily and weekly executions. We can now even take a look at the next part of this dashboard, which shows us stage metrics by status. So we can see our stage level metrics grouped by specific statuses. So for example, we have our source stage, which could be succeeded, failed, canceled, or even stopped. And what you'll see is that we also have a time series of this on the right-hand side. We also we did similar for the build and deploy state. So for build state, you can see 124 succeeded, 30 failed, and we can see that representation on the time series as well as the most recent count being the last daily time series trend. We have 24 successes with 5 failed. Or even on the deploy state being 144 successes, 10 failed, and then today we can actually see the count, 22 succeeded, and then 2 of those failed. However, we can also get a little bit more granular with this by looking at the state metrics by pipeline and status. So now we've even split it into different pipelines. So we can see the sources by pipeline status. We know that both of these succeeded. However, if we take a look at our build states, we can see that 30 failed in the last 2 weeks, and the last data point was 5. Now, by looking at build state by pipeline, we can pretty easily pinpoint which one failed, which would be our demo Java app. Similar to deploy state, where we have our totals and represented as time series, we can quickly see what is responsible for our failure, being the demo.NET app showing us failed. In addition to this, we can also run queries against the log groups where these events are stored, and then pull out even more details and display them as a table. So in this example, we're taking a look at execution IDs by pipeline state, and then just the time in which it occurred. Now, once again, just as with our metric filters, as well as the event rule, as new pipelines are added, as new executions happen, as new applications are added, this dashboard would also pick that up. And to really see this, let's take a look at what we're doing. What we'll do is take a look at the total pipeline executions. And we can go ahead and edit this widget. And first I'd like to show is how we're grabbing the pipeline property. So we're using a dynamic label to populate the pipeline name. And then for the actual details here, we're using a search expression, and we'll walk through what we're doing here. We're using a search expression, and let's walk through what we're doing. So what we're doing is we're searching the code pipeline state execution change for the pipeline stage and state. Our metric name must be a state change. And right now I'm just looking at the state has to be started and our stage has to be source. So we're just looking at how many were started, meaning that if our state is a source and our stage is started, we know that a pipeline kicked off. And then we're just looking at this over the period of a few weeks. Since this is a search expression, we're going to pick up every new occurrence of executions, even as we add new pipelines. A further example of this could be taking a look at our build state daily trends. And what we see here is, once again, we're using dynamic labels to add the last data point. And then inside our search expression, we're taking a look at, we're actually doing a sum of that search result to actually produce a number. And then we're doing this on a daily basis, which then gives us the time series, meaning that as more pipelines are added, as more applications are added, these search expressions are going to be able to pick up those changes, which makes the dashboard dynamic in nature, which can be pretty valuable. On a closing note, and something you may have noticed, is that right now we're only looking at the pipeline executions. However, we also have this same type of data available for code build, code commit, code deploy, and code artifact. Since all of those events are being written to CloudWatch logs, we can use a similar format to now take the logs, convert them to metrics, and start building dashboards or even alarms off of that data, which truly can help operationalize the data that we're getting from these services.
I hope that you found that this demo to be valuable. I'm going to go ahead and now pass it off to my colleague Adnan, who's going to take us into next-gen DevOps.
Thank you very much, Bobby. That was awesome. So, let's kind of round this up by talking about next-gen DevOps or AIOps. What is sort of AIOps or next-gen DevOps? And why do we think of AI/ML, in this DevOps space? Well, AI/ML is sort of the next step to reducing that complexity and automating, right, within DevOps. With machine learning, you can really take your automation to the next level. You can efficiently sift through variety and velocity of data to look for patterns that are kind of important to your organization or problems you may not easily foresee via human involvement. Think of the use cases, right? Analyzing code, looking at patterns for application quality that matters to you, securing applications by identifying usage patterns, managing large sets of alarms and metrics to provide you just only meaningful insights, or that's, the critical stuff, predicting application failure, and more. Let me take the opportunity to briefly highlight what AWS has been doing in this space and walk you through a couple of the services in our portfolio of fully managed DevOps-focused AI services, which will really help your organization utilize ML to really help improve those developer operations as well. So on this slide, what you see represented is a software development lifecycle, right? It basically talks about how developers push code, it goes through reviews, it goes through the process of test and promote, and then finally to production. I'm going to talk about a couple of the services that relate to this that actually utilize machine learning to make and automate this process a little bit more, really help you utilize those deeper learning models as well. So the first service is called CodeGuru. It's a fully managed ML-powered service that helps you do code reviews, and not just syntax checking, but also deeper ML uses detectors to do deeper insights, not only just for best practices, but also security practices as well. Your OWASP top 10, CWEs, and really helps you get those deeper insights into your code. We also, part of CodeGuru is also CodeGuru Profiler, which is all about running and visualizing your application in 24/7 from a developer standpoint in production. Profiler really helps you shows what your application is doing, where the latencies may be, or where the CPU is being utilized more, and really helps developers think about it, right? Developers are always talking about, hey, if something's happening again in the operations world, how can a developer kind of really take a look at that code, really see what's going on from their lens? And that's where CodeGuru Profiler can really help. Last but not least, I want to talk about DevOps Guru as well. It's an ML-powered service that basically looks at your CloudWatch metric data or your CloudWatch vendor metric data to really look for anomalies and sift through, hundreds and thousands of metrics to really find those anomalies or those issues and surface them in a very meaningful way, not only on a single resource, but across multiple resources, and really provide operations with that one single single pane of glass to really be able to root cause and reduce that MTTR. Again, the models are built to sort of find the anomalies for you and really help you sort of get you that insurance policy against these operations as well. One of the benefits of having these services as fully managed is basically that it's on demand. You pay for what you use, and then being fully managed, it allows you to sort of it allows AWS to handle the patching, the scaling, and really handle the underlying infrastructure while you are just concentrating on utilizing the service as what it is and getting the benefits out of it from there. So let's talk about how to get started. Not sure where we're going with this. We've gone through quite a bit of information. Where would you want to start? Where you are? I'm going to hand it over to Bobby here to kind of just talk through some initial steps you could take to get started with adding observability or extending your observability that you already have in your current DevOps. Bobby?
So how do we get started? What's next? What do we take from here? And first off, it's looking at identifying those KPIs, those operational KPIs of both inside your pipeline, so your application, and then also of their pipeline. So what about your pipeline can we make operationally a metric? From those KPIs, identify those metrics, and then implement and verify results, meaning that we need to then implement this process and then understand, are these metrics valuable to us? And then, of course, really when it comes down to everything in DevOps, it's all about iteration over time. Can we use this to identify a gap or something where we can get a little bit better? Do we see where build times could be taking too long? Or maybe that change failure rate is too high. Or we have a high MTTR because we may be lacking observability inside our pipeline or inside our application. These are things that I want you to think of and walk away with today. So take a moment, think about an application that you work on, an application that you support, you develop, or you own, and think about the metrics and different strategies we spoke to today. Would that be useful? And is it worth actually implementing? And with that, I'd like to thank you for your time today.